Hi everyone. This video is about sine wave characteristics, and um, so we'll go through some of the basic sine wave characteristics in terms of measuring voltage qualities and time qualities from your sine wave. I'm going to draw a simple sine wave on the screen here. And so we have a time axis and a voltage axis there. And so one of the key properties that we can read from this graph would be the peak voltage, so V peak, and that's the voltage span from 0 volts to the very top of that waveform. And we actually have the same minus V peak down here at the bottom because this waveform is symmetrical about the zero axis. So this distance here is V peak. Now on an oscilloscope, I would be more likely to measure V peak to peak. So I would be more likely to measure from this top peak to this bottom peak. So this distance here would be V peak to peak. Okay, and in terms of time data, I could measure the period of this waveform. So the period is is in seconds, and it would be the time for one cycle. Now I've only shown one cycle on the screen, but remember this waveform, this sine wave keeps going. Okay, so the period is in seconds, and if we know the period in seconds, we can calculate the frequency, which is 1 over the period, and that is in the units of hertz, which is 1 over seconds is the unit of hertz. Okay. Now let's see a little numerical example for this. So for example, I have a sine wave. I have 8 volts here, minus 8 volts here. Let me label my axis with volts and time. And I have a time value here of 1.5 seconds right there. And let's take these numerical values now from this graph. So V peak is this distance. This is still 0 volts, is V peak. So we see that V peak is going to be 8 volts. Our V peak to peak is going to be this distance, V peak to peak, and we can see that V peak to peak is 8 volts minus 8 volts, which gives us 16 volts. And we should also remember that we know that V peak is twice the, V peak to peak is twice V peak, which would be 2 times 8 volts, and we would still get 16 volts. Okay, so no matter how we calculated that, we got 16 volts. Time-wise, our period of the waveform is here, and I know that 1.5 seconds is what it takes to get half the waveform, so this must be 3 seconds, and if that's 3 seconds, then our frequency is 1 over t, which is 1 over 3 seconds, the seconds on the bottom there, which equals 0.33 hertz. Okay.